In this video, we learn about two-set problem. Here, we are going to discuss the common set problem, describe the different areas, and answer some questions on them. In this Venn diagram, we have the sets A and B and the universal set U. The region in green, that's I, is the region for A only. The region in yellow, that's double I, is for the intersection of A and B. That's the sets of points or the sets of elements that are in both A and B. Now the region in blue, that's region 3, is the sets of elements that are in B only. And the region in IV, that's this entire area, is the region that's neither in A nor B. And U is the universal set. That's when we combine all these sets. That's when we combine A, B, and IV, we are going to have the universal set U. To get the number of elements in A union B, we have to add the number of elements in A plus the number of elements in B, then minus the intersection of A and B. One may ask, why are we subtracting the intersection from it? Because when we count the number of elements in A, we are going to count that of the intersection, right? And also when we count the number of elements in B, we are going to count that of the intersection. So that means that we are counting the intersection twice. So that's why we need to subtract it to get the number of elements in A union B. Example 1. In a class of 50 students, 30 offer economics, 17 offer mathematics, and 7 offer neither mathematics nor economics. How many students offer both? To solve this question, we must first draw a Venn diagram. And so we draw our universal set. That's going to give us a rectangle. So we call this guy U. Now let's draw the sets for mathematics. And so let's use color blue for mathematics. So that's we're going to have this guy to be the sets of the students offering mathematics. So let's say M. Now for those in economics, let's use red for economics. And so we are going to have this guy to be red. So that's E. Now the number of students offering economics is 30. So this guy is going to be 30. And those offering mathematics is giving us 17. And so this guy is going to give us 17. We are told that 7 students offer neither mathematics nor economics. And so this region is going to be 7. Let the number of students offering both subjects be X. And so we have the intersection to be equal to X. So that's we have here to be X. Then the number of students offering mathematics only is going to be 17 minus X. And those offering economics only is going to be 30 minus X. From the question, we are being told that in a class of 50 students, and so the universal set is giving us 50. So which implies that when we add those students offering math only, and those offering both subjects, and those offering economics only, and the students offering neither of these two subjects, we should be able to get the total number of students, which is 50 in this case. Thus, we are going to have 17 minus X plus X plus 30 minus X plus 7 should be equal to 50. When we add all these guys, we should be able to get the universal set. We have minus X and plus X, and so these two guys will go to 0. Thus, we are going to have 17 plus 30 minus X plus 7 is equal to 50. Now, let's simplify this guy. Simplifying this, we are going to have 17 plus 30 plus 7 is going to give us 54. Then minus X is equal to 50. Now let's solve this algebraic equation. To solve this algebraic equation, we are going to move 54 to the right hand side. And so we are going to have minus X is equal to 50 minus 54. Now 54 will become minus because it's going to cross the equal sign. So now let's simplify this. We're going to have minus X is equal to minus 4, which implies that X is equal to 4. Thus, we just have to divide through by minus 1. Thus, 4 students offer both mathematics and economics. Example 2. In a group of 24 girls, 18 like oranges, 7 like bananas, and 4 don't like oranges or bananas. Draw a Venn diagram to illustrate this information. How many girls like both fruits? From the question, we have the universal set U to be equal to 24 because we have in a group of 24 girls, so U is equal to 24. The number of girls who like oranges is giving us 18, and those who like bananas is giving us 7, and those who do not like bananas or oranges, that's O union B complement, is giving us 4. So let's illustrate this on a Venn diagram. So we first have to draw our universal set, which is mostly a rectangle. Now let's use green to denote the sets of bananas, and so this is going to be B, and B is giving us 7. Let's use red to denote the sets of oranges, so this is going to be O, which is giving us 18. And the number of girls who do not like bananas or oranges is giving us 4. And we have our universal set to be equal to 24. Now let's denote the intersection of O and B as X, right? So we are going to have here to be 7 minus X, and this to be 18 minus X. And so this is our Venn diagram representation. Now let's solve for X. That's the number of girls who like both bananas and oranges. So as we did in the first example, when we sum all these guys, we should get the universal set U. So you're going to have 7 minus X plus 18 minus X plus 4 should be equal to 24. We're going to have 7 minus X plus 18 minus X plus 4 should be equal to 24. Now let's solve for X. And so here these two guys will cancel out. So you're going to be left with 7 plus 18 minus X plus 4 is equal to 24. Now let's solve this algebra. So you're going to have 7 plus 18 plus 4, which is going to give us 29. So you're going to have 29 minus X is equal to 24. Now let's solve for X. So minus X will be equal to 24 minus 29. That's minus X is equal to minus 5. Which implies that X is equal to 5. Thus, 5 girls like both fruits. So in our Venn diagram, we are going to have X to be equal to 5. So 7 minus 5 is now 2. And 18 minus 5 is equal to 13. And so we can say that 2 girls like only bananas and 13 girls like only oranges. And 5 like both bananas and oranges. Thank you for watching. See you guys in the next video.